Hey, how you doing? This is Mr. Mitosis here with you, and we're talking about a geometric sequence. Um, so I just wanted to start here by talking about maybe like a real life kind of example. Maybe a cell is shown here dividing by mitosis. How many cells do you think there will be after the next division? So let's say we start at 2 here, and we divide, we're going to end up with 4. We divide again, we got 8. Right, so we got 2, then 4, then 8. How many do you think there are? 16, right? So this should look similar to exponential, right? This is 2 to the first, 2 squared, 2 cubed, and 2 to the fourth. And we've done exponentials before, at least if you're in my Algebra 2 class, we've done exponentials. And so geometric sequences are just an application of exponential equations. And I'll show you what that formula looks like when we get to it. So what is a geometric sequence? Well, a geometric sequence is a sequence of numbers, which is just, a bunch of numbers, term after term, that can be found by multiplying the previous term by the same number to get the next term. So like in this case here, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, times 2 is 64. So we just times 2 each time, and we get the next number. That number that we multiply each time is called the common ratio. And we can find that common ratio just by dividing 8 by 4. You see, we divide the second term by the first term, we get the common ratio. All right, so let's take a look. So here is the formula for the nth term of a geometric sequence. A sub n, which is the nth, this whole thing represents the nth term, right? Equals a sub 1, the first term, times r, which is the common ratio or the rate, to the n minus 1. N is the location of the term that we're looking for. Let's take a look at some examples. So here is our first example. Find the next two terms of the geometric sequence. Well, what we need to do is figure out, what's going on here. So what are we doing each time? Easiest way to do this is take the second term, divide it by the first term. Now you might need a little calculator here to figure this out, but this is going to end up being 1/3. So what I'm doing is I'm dividing each time by 3, right? And dividing each time by 3 is the same as multiplying by 3rd. If you don't know that, it's a key little math question there. Dividing by 3 is the same as multiplying by 1/3. So what I'm doing here is I'm multiplying by 1/3 or dividing by 3 each time. So all I'm going to do is take 36 divided by 3, and then I'm going to get 12. Okay, so that's my next term. Then I'm going to take 12, divide that by 3, and I'm going to get 4, and that's my next term. So these are the next two terms. Easy as that, guys. If I really want to find the next one, 4 divided by 3 is 4/3, so I end up in fractions now. Let's take a look at a practice actually another example. Find the sixth term. Okay, so I'm looking for a sub 6 of this geometric sequence. So a sub 6 is equal to a sub 1 times r to the n minus 1. And remember, remember here that I'm using this formula. A sub n equals a sub 1 times r to the n minus 1. So here we go. Let's do it. It's not that bad. A sub 1 is -3 times -2 to the 5th power. Look, one thing you really got to do, guys, come on. Do not multiply this -3 times a -2. You can't do that. You have to do the power first, right? PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Let's do the exponent first. So, -2 to the 5th power is -32. -32 times -3 is now 96, and that would be our answer. All right. Oh, whoa, I went too fast. Try this practice problem here. It's the same one, similar that I did. I know you got an R as a fraction, but come on, guys. We got to use fractions. Fractions are life. Keep calm. Fraction on. All right, use a little calculator if you need to do this. 2/3 to the 4th power. All right, let's look at another example here. Find a sub n for the geometric sequence. So the first thing I need, excuse me, the first thing I need to do, I need to figure out r. So I'm going to take 30 divided by 60, right? The second term divided by the first term, and that's going to give me 1/2. That is my r. R is 1/2. That's not my answer, guys. That's just r. So now that I have r, I'm going to use my formula. The formula was a sub n equals a sub 1 times r to the n minus 1. A sub n, what are we looking for? A sub 9. N is 9, right? A sub 1 is the first term, 60. R we found was 1/2. N is 9. 60 times 1/2 to the 8th power. Whoo! 1/2 to the 8th power. To the 8th power. That's going to be 256. All right? That's 2 to the 8th. 1 to the 8th is just 1. When I simplify that guy out here, I'm going to get 15 over 64. And you might need a calculator to do that. All right, I think all I got is for you now is one more practice problem. So let's take a look. Try this one out, just like the problem I just did. What'd you get? Did you get that? I hope so. Again, you might need a little calculator here to do -3 to the 6th. I wouldn't expect you to know how to do -3 to the 6th power just out of your head. But if you can, you're awesome. All right. All right, that's it. That's all there was. 6 minutes, guys. Almost 7. Boom. Ciao. Bye.